let's talk about a classic Azure security dilemma: service endpoints versus private endpoints. When you need to lock down your access to services like Azure Storage or SQL, which one do you actually use? We're going to look at the original solution, see exactly why it got replaced, and by the end of this, you'll know exactly which one to choose.
Okay, so think about this for a second. Most of those great Azure Platform as a Service or PaaS offerings, they have a public endpoint right out of the box. And that's great for getting started, but from a security perspective, it's a huge red flag. You definitely don't want your sensitive corporate data just traveling over the public internet. So the big question is, how do you lock that down and create a truly private, secure connection?
To answer that, we've got to go back in time a little bit and look at Microsoft's first swing at solving this exact problem: how to stop your data from ever touching the public internet in the first place.
And that solution was the service endpoint. Now, the idea here was actually pretty clever. Instead of your traffic leaving your virtual network and hopping onto the public internet, a service endpoint carves out an optimized direct route right over the Azure backbone. It essentially just tells the Azure service, hey, any traffic you see coming from this specific virtual network, yeah, you can trust it.
The real magic behind this is all about identity. Before you enable an endpoint, that Azure service just sees a request coming from some public IP address. But the moment you flip that switch, the source IP changes to a private IP from inside your VNet. That simple change is the whole key. It lets you write firewall rules on the service that say, only accept traffic from my virtual network and block everything else.
And for its time, this was fantastic. You got a massive security boost because you could completely cut off public internet access. Your traffic was taking the best route possible, staying on Microsoft's own super fast private network. And the setup, it was incredibly simple. A few clicks, no complex gateways to manage. What's not to love?
Well, there was a huge catch, a real deal breaker for a lot of companies. See, service endpoints extend your network to the service, but they don't bring the service into your network. And what that means is they're completely inaccessible from your on-premises network over a VPN or an express route. So for any organization with a hybrid setup, this just wasn't going to work.
And that major limitation is exactly what paved the way for the modern and, frankly, the now highly recommended solution: Azure Private Link and its private endpoints.
And hey, don't just take my word for it. This quote is pulled directly from Microsoft's own documentation. They are explicitly telling everyone to move to this new model. So let's get into why this is the new standard.
A private endpoint is a total game changer. It's not just a routing trick, it's an actual network interface, a NIC, just like the one on a virtual machine that gets deployed inside your virtual network. It gets a private IP address from your VNet's address space. This is the big shift. You're not just telling the service to trust you anymore. You are literally pulling a piece of that Azure service directly into your private world.
This new way also comes with a much more secure consent-based model. See, with service endpoints, you just turned it on. But with private endpoints, there's an approval workflow. If you want to connect to a resource that you don't own, the resource owner has to get a request, and they have to explicitly approve the connection. This prevents any kind of unauthorized access and gives the resource owner complete control.
Okay, so let's put these two head to head, this showdown. This is where you'll really see why the modern approach is just so much better.
This table really says it all, doesn't it? Service endpoints extend your VNet's identity. Private endpoints bring the service right inside. But the absolute killer feature, the one that changes everything, is right here: on-premises access. With private endpoints, it just works, period. Plus, you get way more granular. You can secure one specific storage account, not just the entire storage service. It really solves every single limitation of the old way.
Now, before you run off and start deploying private endpoints everywhere, there is one critical implementation detail you absolutely, positively cannot forget about.
And I honestly cannot stress this enough. When you switch from a public endpoint to a private one, you have to tell your applications how to find the new location. That means you have to configure your DNS. If you skip this step, you'll have this beautiful, secure, private connection, and your applications will have no idea it exists. They'll just keep trying to hit the old public IP, and the connection will just time out and fail.
So here's what's happening under the hood. Your application's code, it doesn't change a bit. It's still trying to connect to the same public name, like storage.blob.core.windows.net. Your job is to set up your DNS so that when a request for that name comes from inside your VNet, it resolves to the new private IP of your endpoint, not the public one. And luckily, this is exactly what Azure private DNS zones are designed to do for you pretty much automatically. Okay, so let's wrap all of this up. What does a modern, private, and truly secure Azure strategy really look like?
The key takeaway here is crystal clear. Private Link and the private endpoints it uses is the future of private connectivity in Azure. It gives your PaaS services a real, first-class, private IP address right inside your network. It natively supports hybrid connections, which is huge. It lets you use standard tools like network security groups for even more control. And, well, it's the official recommended standard for all new deployments.
And that really just leaves us with one final question for you to think about for your own environment. You might have firewalls, you might have all sorts of network rules in place, but if your critical PaaS services are still listening on public endpoints, is your cloud perimeter truly as private as you think it is?